Hello, class. This is Mr. Eggleston, and this is the lecture for Algebra 1, Lesson 4.7, Solving Systems of Linear Inequalities. We saw last time how to graph one linear inequality, where we had to graph the line, the boundary line, and decide which side to shade of the line that we drew. And we shade in the correct side. Solving systems of linear inequalities, it's the same thing, but now just like when we had to solve a system of linear equations, like y equals 2x minus 1 and y equals x plus 3, you would graph both lines and see where they cross and call that the solution. So you'd have like here and up 1, 2 over 1. There's another line. You'd have one graph being like this, and the other graph 1, 2, 3, up 1 over 1, up 1 over 1, up 1 over 1. That's the way. Okay, so we got this, and we would look to see where they cross and call that the solution. We do the same thing with these, except for now we graph both lines, both boundary lines, and we shade, and we see where the shadings overlap. For example, on number 1, y is greater than or equal to 2x plus 3. It's a y, this is going to be the white line. White lines. Okay, so it's right here. It's right there. You go up 1, 2 to the right 1, down 1, 2 to the left 1, down 1, 2 to the left 1, 1, 2 to the left 1. Look at this, 1, 2 to the left 1. I like to put as many dots down as possible. I then graph the line. Okay. And yes, it looks horrible. That's okay. We got it right there. All right, and it's a solid line. All the rules apply. It's a solid line because it's greater than or equal to. We shade above the line because we want all the y's greater than this is the solution. So we would shade up here. Oh, can't see that. So we shade up there. All right. Now graph. Notice I didn't shade all over the place. It's because we have to graph the other line, boundary line, and shade, and see where the two shadings overlap. So to do that, I'm going to use the green, and this one's a green line, has a y-intercept of -1, up 1, 2 to the right, 1, 2, 3, down 1, 2 to the left, 1, 2, 3, down 1, 2 to the left, 1, 2. Okay, it's off. So here we go. Again, I do this long tail on the iPad so I can just move this up. So there we go. All right. And now we got to shade the green. And the green shaded. Do I even have a green color for shading? I'll make it yellow. All right. So this is yellow shaded. All right. And so we have to decide it's all y less than the line 2/3 x minus 1, and less than it's down here. So if you carry out the shading to its obvious conclusion, okay, the overlap is right here. And we call this the solution. It's a little piece right there, because that's where the shading of the inequalities overlap. In other words, this is the only region that the points will satisfy both the top inequality and the lower inequality. So it's very similar, and that's it. That's the answer. It's very similar to solving systems of equations graphically. Because remember, when we were solving systems of equations graphically, like up here, you graph both lines, which represent the solutions of the equation like 2x minus 1 is represented by this line right here. The solutions to x plus 3 is represented by this really bad line right there. And we look to see where they cross, and that's the point that works in both equations. Well, now we do the same, but now we're looking to see the region that satisfies both inequalities. We'll do another one, just like the other one. The top line will be blue. They're both going to be solid, just like on number 1. And the bottom one's going to be, that's too close, white. Okay, so we want to graph y equals 3x plus 2. So y-intercept of 2, slope of 3. So we go up 1, 2, 3 to the right 1. We can go down 1, 2, 3 to the left 1. Just reverse both. Now up 3 to the right one's positive 3, but so is down 3 to the left 1. Do it again. And we have this. Okay. Now it's solid, and we have to graph the region below, right? Because this is y is less than. So to do that, below would be on this side. So there's the solution. I don't do a whole bunch because I want to graph the other line. So this is y is less than negative x minus 2. Y-intercept of negative 2 minus x is negative 1 slope. And we go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, up 1 to the left 1. All I'm doing is the stuff we learned about in the previous unit. And there we go. And again, it's a solid line. Okay, so if this had been a system of equations, we would say that the point where they intersect is the solution right there. But this is a system of inequalities. So for the white line, we are looking for all y less than the y's on this line. So that means we shade below. So it's down here, and the other shading's here. And you can see that where they overlap is right here. And that region is the solution. Every point within that double shaded area works in both inequalities. Satisfies the top, satisfies the bottom. All right, I'll do one more, and we'll do 3 because it's greater than or equal to and just a less than. I will use the colors green for the top line and the color hot pink for the bottom line. Okay. Now we're going to graph y equals 5/3 x plus 2. Y-intercept of 2, we would go up 1, 2, 3. Oh, it's off the grid. So we go down 1, 2, 3, 4, 5. To the left, 3, 1, 2, 3. Negative over a negative is a positive, and you see you do get a positive slope. All right, now we're going to connect the dots with a solid line. Now, this is just because I'm using I'm using Notability, the iPad. I drew it extra long so I could just scoot it down so you can see the line covers the whole grid. All right, y is greater than, which means all the y outputs are on top of the line. So this is the solution in this region, and it's all of this, right? So there you go. Now for the pink line, we graph y equals negative 3. Oh, sorry. We graph y equals negative 3. That's just a horizontal line with 0 slope. Oops, sorry. So it's right here. This line is broken. Okay, so I'm just going to do the old switch, select the line and change the style so that's broken. Oh, there are a bunch of broken dots. How about if I change it to a bunch of dashed lines? There we go. Now we want y is less than, which is all the numbers below -3. And so that solution is, oh, they're both yellow. So let me, I don't know, red. So it's, oh, you can't see that. Let's go white. All right, so that's down here. And you can see the solution is just this little tiny corner right here where the two are overlapping. So this is the solution. Right there. They're all pretty much the same. The trick is to graph the line correctly. And that's it. There you go. Bye-bye.